Learning the syntax of a coding language isn't enough. You need to learn how to think like a programmer by improving your problem-solving skills. When first learning to code, it's easy to feel lost. Everything seems cryptic. When I started coding, I had no experience with code. I didn't have a mentor. I didn't have a computer science degree. I had no direction. I wanted to learn how to code because I needed a website for one of my businesses. And I got some quotes that were up to $20,000 for the type of website I wanted. So I figured I'd learn how to code a website myself. I went from knowing absolutely nothing to coding my first website in under a year. I studied for about 3 hours per day, and this put me on an emotional roller coaster. Frustration, confusion, lack of direction. I wanted to give up nearly every single day. I didn't know anyone who knew how to code, so I had nobody that I could ask for help. So what did I do? I read every single book I could get my hands on. I watched every video I could, read all the documentation pages, and reverse engineered code that I found online. I created basic websites and continuously refactored them, making them more complex. It was overwhelming. Quick question: do you feel overwhelmed? Don't. Every single programmer started from step 1, the hello world or foobar type code. Most tutorials focus on teaching you the syntax of a coding language. You need to learn the grammar of a language. The nouns, the verbs, the adjectives, the coders are variables, functions, classes, objects, and more. One thing I wish I would have done sooner was to learn how to think like a programmer. I focused more on learning the syntax of the various coding languages, and I was able to get results. But learning to think like a programmer, that came much later. At its core, programming is about problem solving, thinking logically, and breaking down a problem into small steps in order to find a solution. Problem solving is a meta skill. The steps we normally use in terms of problem solving are: try a potential solution. If that doesn't work, then try another potential solution. And if that doesn't work, then try yet another potential solution. It's like copying code found online that might or might not be a solution to your problem. This might work, but are you really learning? Or are you just using a trial and error approach? So again, what does it mean to think like a programmer? It's having the ability to see a problem from one angle, then stepping back and looking at the same problem from a different perspective. You do this until you find a solution. This is why you should use a problem-solving framework. I like to use a 5-step approach to problem solving. First, understand the problem. Second, plan out your solution. Third, divide the problem into smaller parts. Fourth, if you get stuck, then take a step back. Breathe and do another activity, ideally a creative one. 5. Practice different approaches to see which one works and test your solution thoroughly. For example, let's try this out on a reason that most people say they cannot become a programmer. You might hear this often, or you might be saying this to yourself: you don't have enough time to learn how to code. Now, I can easily give you my schedule. This is kind of like copying code that you find online. But what if my schedule doesn't work for you? We all have different life situations. So let's see, how can you solve the problem of not having enough time to learn how to code? Well, you already took the first step towards problem solving. You identified the problem. Now you have to figure out why you don't have enough time. Understand the problem. Research the problem. Visualize your day from the moment you wake up to the point when you go to sleep. Here's a possible schedule. Wake up at 7, school or work by 9, lunch by 12, leave work or school by 4 or 5, home by 6, dinner by 7, sleep by 11. Let's break this down another way. Sleep about 8 hours a night. Breakfast is about 30 minutes. Grooming is about another 30 minutes. Getting to school or work is about 30 to 60 minutes in travel time. You're at work or school for about 8 hours per day. Lunch is about an hour. Getting home from school or work is about another 30 to 60 minutes. Now you gotta eat, right? So preparing and eating food is about another 45 to 90 minutes. And then cleaning up is about another 30 to 60 minutes. Then you have about 3 hours of miscellaneous time. And then bed by 11. Do you see what we've done? We've broken down our day, the problem, into its most basic parts. Now we can move on to the next step, which is analyzing our schedule further to see when we can learn how to code. Ask yourself the right questions. Are there gaps in my day that I can use to focus on learning? Are there activities that eat away at my day without me realizing? I'm talking about social media, Netflix, TV, etc. Most cell phones have a feature to see how much time you spent on it and on what. Can I wake up at 6 a.m.? Can I read a book about code while on the train? Can I listen to a developer podcast while driving to work or school? Can I use my cell phone to look at code examples or watch coding videos while at lunch? Can I use my travel time home to listen or read about code? Can I maybe go to a local meetup where the topic is about the coding language I'm looking to learn? Can I go to sleep 1 hour later to read a book on code? Reading a code book is a great way to fall asleep. Asking the right questions will lead you down the path to creating a solution. This will be helpful when taking the code syntax that you learn and creating a solution with all those functions, classes, objects, variables, conditionals, and others. Plan. Figure out a strategy to help you get more study time throughout the day. Divide. Break apart your day and activities to figure out when you can benefit the most from studying. Some people are sharper in the morning, others in the afternoon or night. Did you get stuck? Maybe you tried adjusting one part of your schedule, but nothing sticks. Try another time to adjust. Practice. Try each strategy out for a week and see if you're getting positive results. Applying this approach of really understanding your problem, planning out a potential solution, dividing it into smaller parts, if stuck, trying a different approach, and practicing or testing your solution really isn't that hard. It just takes effort and time. Okay, so how does this actually apply to code? Well, here's an example code project. A contact form. Understand it. You or a client will need a contact form for getting information from an online lead. They will need the person's name, email, number, address, and some extra information. They also want to prevent spam bots from taking up space within the database. A contact form will need input fields that need to be validated, sanitized, processed, and inserted into a MySQL database. So the plan. Sketch out what the contact form should look like and what should happen when a person types their information into each input field. Divide. Use HTML to handle the markup. HTML5 has some validation features. JavaScript can also be used for some validation as well. PHP can be used on the server to handle the processing, aka validation and sanitation. And PHP can also be used to insert the form data into the MySQL database. A honeypot invisible form field can determine if the form is from a real person or a bot. A CAPTCHA can also be used for this. If you get stuck, Google and Stack Overflow are a developer's best friend. Also try to figure out at what point your potential solution isn't working. Practice. Test thoroughly. Even if it works, try to think like a human thinks, like a person thinks. Is the user experience a good one? Have you validated and sanitized the inputs? Have you tested your honeypot or CAPTCHA? These are questions that you have to ask. Now, what are other activities you can do in order to improve your problem-solving skills and think like a programmer? Have some fun. Play some games. Chess, Sudoku, Go, Monopoly, Perfection, and video games. Playing games typically means finding a solution to a problem, how to win the game. The most important thing to remember is be patient and be persistent. Now, here are a few quotes that I think are helpful. Everyone in this country should learn to program a computer because it teaches you to think. The biggest mistake I see new programmers make is focusing on learning the syntax instead of learning how to solve problems. Demonstrating computational thinking or the ability to break down large complex problems is just as valuable, if not more so, than the baseline technical skills required for a job. Alright, so now you know that learning the syntax of a coding language just isn't enough. You have to learn how to think like a programmer. If you found this video helpful, give it a big thumbs up. Don't forget to subscribe. Check out a few other videos I have on this channel. And I will see you in the next one. Happy coding.